Hello children, I welcome you all to K-Tech High School and Junior College. Children, in our last session we have started our lesson number 7, Metals and Non-Metals, where we studied the physical properties of metals and non-metals. In our today's lecture, we shall be learning the chemical properties of metals and non-metals. So, we shall begin with our chemical properties of metals and non-metals of lesson number 7. So, let's begin. Chemical properties of metal. The first property we have electronic configuration. Electronic configuration is the basis of the chemical behavior of elements. Majority of metals have up to 3 electrons in their outermost shell. So, to understand it better, let's see this table where we have the metals like sodium, magnesium and aluminium. In the picture you can observe we have up to 3 electrons present in the outermost shell. So, this is the property of electronic configuration of metals. Now, let's see the second property. Formation of ions. Let's see what it is. Metals have a tendency to lose their valence electrons to form positively charged ions, that is, cations. Look at this picture. There are some examples given. The first one is sodium, which has the electronic configuration 2, 8, 1. That means in the outermost shell it has only 1 electron. So it will lose that 1 electron and become 2, 8. That is, it will form a positively charged sodium ion and plus 1 electron is looped. The second example is magnesium, where the electronic configuration is 2, 8, 2. So, in the outermost shell, it has only 2 electrons. By losing the 2 electrons, it will form the positively charged magnesium ion with electronic configuration 2 and 8. The next chemical property of metal we have reaction with oxygen. Metals combine with oxygen to form metal oxides. Metal plus oxide gives us metal oxides. Understood? Let's see some example. Now see here children. There is a table where we have the list of some metals starting from potassium, sodium to platinum. It also shows an arrow, a downward arrow, and it is also written in above the most reactive and below less reactive. So it states that the metals like sodium, potassium, they are most reactive with oxygen, while silver, gold, platinum, they are less reactive with oxygen. So when these metals react with oxygen, they form their oxides. Potassium plus oxygen forms potassium oxide, that is K2 plus O gives us K2O. Understanding, children? Magnesium plus oxygen gives magnesium oxide. Zinc plus oxygen gives us zinc oxide. You can find out similarly for the rest of the metals also. Understood, children? Now look here. If we take potassium oxide in a beaker. Now, if we dip a red litmus paper into potassium oxide, it turns blue, which means it is basic in nature. So, metal oxides are basic in nature. Metal oxides reacts with acid to form salt and water. Here we have an example. Al2O3, which is base, plus 6HCl, hydrochloric acid, which is an acid. When it combines together, it forms AlCl3, which is a salt, plus H2O, that is water. Metal oxides plus acid gives salt plus water. Is it easy to understand? Yes, children. Now, let's see the next property. The next chemical property we have reactions with acid. Here, we have to do an experiment. What we have to do here is take dilute hydrochloric acid in a test tube. Then add zinc dust to it. Now take a glowing splinter near the mouth of the test tube. Observe the glowing splinter. You will notice some sound coming out of it. This splint burns with a popping sound. So what is the conclusion over here? Hydrogen gas burns with a pop. So this is the test for hydrogen gas. Are you understanding this? What we have observed from this experiment? Yes, children. Now, most of the metals react with dilute acids to form metal salts while hydrogen gas is released. So, metals plus dilute acid gives salt plus hydrogen gas. This must have been understood with the help of the experiment which we have just done. The next chemical property is reaction with water. Most metals do not show any observable and fast reaction with cold water. Most of the metals, but some metals like sodium and potassium react with cold water, as you can see in this picture. Hydrogen gas can burn in the air, and also if we put red litmus paper, it turns into blue, which indicate it is basic in nature. Are you understanding this, children? Isn't it easy to understand with the help of this experiment? Yes. Now children, moving ahead, let's study the chemical properties of non-metals. To begin with, the first chemical property we have is electronic configuration. Most of the non-metals have 4 to 7 electrons in their valence shell. Look at this table shown here. The first non-metal, that is nitrogen, electronic configuration is 2, 5. That means there are 5 electrons in the outermost shell, that is orbit. The next, oxygen, whose electronic configuration is 2, 6. And chlorine, 17, electronic configuration is 2, 8, 7. That means most of the non-metals have 4 to 7 electrons in their valence shell. It must be clear with these examples. Isn't it, children? Yes. Let's move to the next property, next chemical property of non-metal. The second property of non-metal is formation of ions. Non-metals have a tendency to accept electrons in their valence shell to form negatively charged ions called as anions. Now look at these examples. The first one is chlorine, whose electronic configuration is 2, 8, 7. It means only one electron it needs to complete the outermost shell, outermost orbit, that is its octet. So it will accept one electron and form 2, 8, 8, that is chloride ion. The next example is oxygen. Electronic configuration is 2, 6. It needs 2 electrons to complete its octet. So we'll accept 2 electron and form oxide ion 2, 8. Third one is nitrogen 2, 5. It will accept 3 electron to complete its octet and it will form nitrite ion with electronic configuration 2, 8. Understood? I hope with these examples you must have understood the formation of ion, the chemical property of non-metals. The next property we shall study is reaction with oxygen. Non-metals combine with oxygen to form non-metal oxides. That means non-metal plus oxides will give us non-metal oxide. Got it? Non-metal oxides react with bases to form soluble salt and water. CO2 plus 2NaOH. So it will give Na2CO3 plus H2O. So this is the reaction with oxygen. That is hydroxide with we will get. Now the oxides of non-metal react with water to form an acid. Let us understand this with some example. Look here children. CO2 plus H2O will give H2CO3. That is carbonic acid. See the combination H2 plus C and oxygen atoms are how many? 3. So H2CO3. Same with SO2 plus H2O will give H2SO3. That is sulfurous acid. And the third one SO3 plus H2O. So it will give H2SO4. That is sulfuric acid. So these were some examples of the oxides where the oxides of non-metals react with water to form acid. So with this example, you must have understood it clearly. Isn't it, children? Is it helpful for you? Yes. The fourth property is non-metals do not react with dilute acids. They do not react with any kind of dilute acids. Okay, children? Now, let's see the summary of what we have learned in today's lecture. Chemical properties of metals. Electronic configuration. Formation of ions. Reaction with oxygen. Reaction with acid. And reaction with water. Chemical properties of non-metals. Electronic configuration. Formation of ions. Reaction with oxygen, and non-metals do not react with any dilute acid. Let's check the notes. First, new words, then we will write glossary. Question number 1, fill in the blanks. Question number 2, state whether the following statements are true or false. Followed by question number 3, match the columns, then distinguish between metals and non-metals based on chemical properties. Question number 5, we need to write the 3 experiments to study the process of rusting and answer the following questions. That's all for today's session, children. I hope you all must have understood. Thank you. Take care. Bye children.